Okay, now I will introduce the lab. Hi, everybody. I will introduce the lab number 2, measurement and density lab. This is going to be a formal lab report. Again, you need to use the rubric that is here. I shared that with you. It is under the Start Here module here. You're going to create a Word document similar to this one here, where you are going to have all the sections outlined here, as we did in the first orientation. Okay, now the second part here is I want to access the lab. Is going to be here under measurement and density lab. Of course, here you're gonna find you're gonna find this video. I might have that in like 2 separate videos. The reason is I'm using 2 systems in recording. This is here the rubric for the measurement lab. I'm pretty sure it's everything here, and also okay. Let me just here, I want to get this here. Okay, and here this submission is going to take you to Gradescope. All right, excellent. And here the instructions. Okay, the first one here, it is a PowerPoint that we are talking about the importance of measurements and how to use 3 I will say tools. One of them is the ruler. You know about it. Verniers, these are new. Micrometers are actually new. And how we are going to determine the uncertainty, and we will do this for all the devices. Now, we need to know about the uncertainty, but we will not apply it this semester. Okay, now I will say for the ruler, it is marked in millimeters. It is really good for measurements that they are 10 centimeters or greater. But if the measurement is really, really small, we will not be able to, to use a ruler. Now, here showing you a sample measurement for the ruler. Of course, we said it is millimeters, but these numbers here are centimeters. Then here I will say this is 4, 1, 2, 3, and the reading is between 4.3 and 4.3 and 4.4. This is the reason why we are going to say, okay, my reading, it is 4.3 plus or minus 1/2 a division. 1/2 a division here, the division is 1 millimeter, then it is half of it, which is going to be 0.05 centimeter. No, the measurement is made at 2 ends. Don't do like the measurement from the first one is going to have uncertainty and the second one going to have uncertainty. Then at that moment you need to add both here, like this one. Okay, then here we are going to say if I will do 2 ends here, then my measurements is going to have more uncertainty, because I need to add 0.05 for the first reading, and I'm gonna add another 0.05 for the second one, because I will say the uncertainties, they don't subtract, they add. Then if you repeated the measurement twice, is gonna have twice the uncertainty. Now for the vernier, we're gonna have 2 scales. Okay, there is a main scale and there is the vernier scale. And let me, while I'm doing this, I want to show you the vernier that you have in your handouts, the one that we are going to use actually in measurement. Let me get the student view so that I'm sure that you are able to access it. Now, if we go back here again, not the simulation here. This is the vernier reading. Okay, then look here. This is your main scale for the vernier. 1, 2, 3, 4, 5, 6. Can you see it? This is the main scale. This is the other scale, which we call it the vernier scale. All right. Now, let's go back to the PowerPoint. Okay. Then now here, this is the main scale and this is the vernier scale. Now the vernier scale, it starts with 0, but then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now they are really, I will say, here on the main scale, we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, if we look at the spaces, they are 9. Now, it is working on this idea. Now, how we are going to measure? Look first at the main scale and then recognize where is the 0 hitting. Okay, this is here 1, 1.1, 1.2, and then I'm gonna stop. Then I will stop at the 0. Again, I want to show you my vernier. Don't stop here. Your reading is gonna start here. This is the 0 of the vernier. It's not the edge of the vernier. All right, then here I'm gonna, where is the 0, not where is the edge. I'm gonna stop the reading. Then I will say 1, 1.1, 1.2. Now, after that, if you look at this division here on the vernier, it's not actually lined up with the one on top. This one also, it's not. Now look at this one. It is lined up kind of. Okay, then here I will say, I will count. This is 1, 2, 3. Then my reading here is going to be 1.23 centimeters. Again, for the reading of the vernier, I will say here, this is 1, 1.2, 1.1, 1.2. I'm going to stop. Then this reading was taken from the main, which is the ruler. And the second one is going to be taken from the vernier. You are going to try to find the first line that is lined up with the one on top. Okay, usually it's going to be one of them or like two of them. Take the first one. Then this is 1, 2, 3. Okay, and then my reading is 1.3 centimeters. The vernier part of reading is really a subtraction because we did it in a way. Okay, forget about this one here because I feel it's confusing for you. Okay, now I will say the uncertainty now in that vernier, it is 0.01 centimeter because this is where I will not be able to be certain about my reading. Okay, forget about this one as well. I don't need all. I'm gonna go to, because of course we have different verniers also, and this is another type. We don't want to go over this. We want to go for the micrometer. But just before that, whenever you are going to read this, you're going to read it twice. If you are two students in one group, each is gonna perform 2 readings. You're gonna read the first time and then you're gonna forget about it completely. You don't tell your partner about your readings until you share it with him or her. Then you are going to read 2 this reading 2 times, because in the table I'm asking this I'm asking this for this. I will show you also another time what I mean by this. Now also I want to go and share also my micrometer here. Okay, because my micrometer is gonna be here. All right, and then here I will say for the micrometer, each mark here is 1 millimeter, and the one below is 1/2. Then if you look here, this is 1 millimeter, 2, 3, 4, 5, 6. If you will be able to see the half, then you're gonna say 6.5. If you are not able to see it, you will say 6.00. And then after that, we have that round scale here, the circular scale. You're gonna look at it. Each mark here, it is 0.01. Then this is 5, 6, 7. That's 7 multiplied by 0.01 is gonna be 0.07. And I add it to 6.5 plus my 0.07, then my reading is gonna be 6.57. Again, now, again, the reading is 2 parts. 1, 2, 3, 4, 5, 6, and a half. Then you're gonna say 6.5. This is from the main scale. From the circular scale, sorry, I have here 5, 6, 7. Each is 0.01. Then 7 times 0.01, you're gonna say it's gonna be 0.07 added to the 6.5. This is gonna be 6.57. Of course, here we are talking about like actual micrometers that you're gonna do in the lab. Do not over tighten the micrometers. Do not store the closed jaws, and like many things related. I don't want to go over this. Okay, let's go back to, again, for the micrometer, you are going to repeat the measurement twice, and your partner is gonna repeat it twice. Also for the scale. Now, okay, I will show you also more reading like the virtual. I will go with you, but just let's go over the table here. I should see that table here in your data section. 1, 2, 3, 4 is the number of readings that you're gonna get for the balance, for the vernier, for the micrometer. Each student in the group should do the measurement twice. They should be different, okay? And you can make them different because actually maybe sometimes I will take the first line to be lined up and then maybe the second. Then it's easy, okay? And after you got, okay, this is the scale, and I will show you also the virtual scale, how we're gonna use it. It has 3 beams, 1 for the hundredths, and 1 for the tenths, and 1 for the ones and the decimals. Then you're gonna, like, your reading is gonna be adding, this is here, like how many, the 20, the 20 is, here the hundreds, here the tenths, and then the hundreds, you add them, and you add plus the grams or the ones, plus the decimals. I will show you because I don't want to read it for you, this one. Also, you will do the vernier, each one twice, and you're gonna do the micrometer twice. And then after that, each column is gonna represent the mass, the length, and the diameter of one cylinder. You are going to create a new table under calculation and calculate the volume for each attempt and density. Then I'm gonna see a table that is gonna have volume and density calculated. You can use Excel to calculate these for yourself, and then you are going to list sample calculation. Now, since we are going to use Excel, then what is really needed here, two files. One of them is the Word document, which is gonna have the formal lab report and also the Excel sheet. Predict which type of metal is this. Okay, you're gonna search for the density table and try, like in your textbook, you're gonna find one, or you can search the net. Calculate then the percent difference between your average value and the percent difference. And here, you know what I want, because okay, let me just leave that here, and just I'm gonna add here, like I wanna maybe, okay, for this lab, it should be a formal lab report. You should submit 2 files. Okay, and I mentioned what are these 2 files. They will be the Excel file plus the Word document that is gonna be your file, your lab report. Now also, this is the virtual scale simulation. I want to show you here. Okay, if you look here, I have 3 scales. The first reading is 0, and this one is 200, and that one is 7, here 8.5, I believe. Then I will say here, what did I say? I said 200, and then for that one I said 8. Okay, and that one, oh yeah, it's showing me now. It is either I can say 8.5 or 8.4. I think yes. Okay, check. Wrong. Then they want me maybe to say 5. Did I do a mistake? Oh, I did. Oh yeah, this is the 200. This is the 200. And that one is the 0. I'm sorry. Okay, and then 8.5 or 8.4, I believe they gonna. Okay, then yes, it is correct. Okay, then this is really how you are going to read it. Like this is another reading here. Like here, the hundreds is 0, and then I have here 6. Okay, 60. And then here, that is not, okay, that one is 0, and then it is, okay, this one is 0. Let me write this 0, and that one, the last one, is showing me here. It is 0.5, 6, 7, 8. I can say 8. Ooh, correct. Okay. And this is, you can practice as you like. Here for the vernier, this is my virtual vernier. Yeah, but this one is different from yours. Okay, I will read here 3.123, then 3.3. And then I'm gonna try to find where it's gonna line up. Maybe it's gonna be 4 or 4.5. Okay, because I don't want to confuse you here. Let's say then it's gonna be 3.34. And let's say the micrometer, like it's like more standardized. Okay, and let me get a reading. I want to just wait a little bit and then, okay, here I will say this is 1.5. It's almost like 1.5. And then after that, 21, 22, 23, 24. Then this is going to be 1.5 plus, I believe it's 2. Okay, let me change this one. Okay, let me get another one because this is confusing. This one, let me have more numbers. Okay, I want to get this one where, okay, how I'm gonna stop it. Okay, now look here, this is 2. Oh, this is 2.2. Oh, this one is different. Okay, then this one, it is here, it is divided into 4. Then it's not gonna be only 2.5. This is gonna be 2.25 and then plus 0.05. Okay, I will say no, 0.04. Actually, we don't take the 5 because it's here. Then it's gonna be 0.225 plus 0.05, and this is the reason why it is 0.2293, and that one is in centimeters. Okay, I did not find the other micrometer, but this one is very similar to the handout. Thank you, and let's I want to share with you my screen. Maybe without a recording, I will just give you like more instructions on how to do the calculation for the cylinder and find the density in a little bit.